Hello students, so today we are going to start our new topic, that force between multiple charges. Basically in this topic, suppose whatever we have studied in Coulomb's law, we have studied between two charges, but if there are more than two charges, okay, then what we will do, that is known as, there we will use superposition principle or force between multiple charges. Suppose you can see in the diagram over here that there is a charge q1, charge q2 and charge q3. Okay, so we need to find basically here that force on charge q1 due to charge q2 and q3. As you can see, the distance of q1, q2 and q3 respectively r1, r2 and r3 from the origin. But if you want to find the distance between charge q1 and q2, it will be what? r12, position vector of charge 1 with respect to charge 2. Similarly, r13 is the position vector of charge 1 with respect to charge 3. Now as you can see in the diagram, the charge q1 and q2 are both similar charges, so there will be a repulsive force on charge q1 due to charge q2, which is F12. Okay, and again q3 and q1 are also similar charges. There will be again a repulsive force on charge 1 due to charge 3. It is known as what? F13. Now you can see F12 and F13 are the we can represent this as the two arms or the two sides, two adjacent sides of a parallelogram. And according to Vector's law of addition of parallelogram, we know that the diagonal will give the resultant. Okay, so here if you want to find the total force on charge F1, we have done some mathematics over here. There are some derivations. F12 equals to what? 1 by 4 pi epsilon naught q1 q2 by r12 square. r12 hat is a unit vector which will give you the direction. Similarly, F13 also will find, and suppose if they are, in this diagram we have shown two charges, but if there are number of charges, then we write what? F1n dot 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 F1n 1 by 4 pi epsilon naught q1 q2 q1 qn by r1n square. And if you want to find this, you need to add all the forces that is acting on the charge q1. So we have added over here F12 plus F13 plus dot 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 F1 hat, F1 vector. As you know that 1 by 4 pi epsilon naught and q1 is common in all, so we have taken it common. What is left there? Left thing is what? q2 in the first, then q3, then qn, then r12 square, then r13 square, then r1n square, then the direction also unit vector also. So as you can see, we have done over here what? Summation. You know in maths we do summation or integration sometime. Here we are using summation. You must know the difference between summation and integration. Okay, so here we are doing what? Summation, and we are representing here what? qi by r1i square and r1i hat. What is I over here? I may be anything from 1 to n. Okay, the vector sum is obtained by using law of vector addition. In this way we can find the force on a single charge due to multiple charges in the surroundings. Now we are going for the new topic, electric field. What is electric field? First, suppose you know, first you know or not, tell me electric field. Electric field is what? Electric field is nothing but the space surrounds a charge up to which its effect can be experienced. This is a basic thing all of us know, that electric field is a region surrounds a charge up to which its effect can be felt or its effect can be experienced. But sir, how to find an electric field? As you can see in the diagram, there is a charge q at the point O. This is known as source charge, and there is a circle over there. The circle is representing the electric field due to that charge. Okay, and you can see on the right hand side a charge q0, which is known as what? Test charge. Okay, the test charge will always take positive. If both the charges are same, there will be a force of repulsion. The force of repulsion is what? F vector, as you can see in the diagram over here. Okay, now the definition of electric field is okay, but how we can find the electric field? For what is the formula? The formula of electric field is the force experienced on unit charge, and whenever we say unit, we divide that quantity by that thing. So electric field equals to what? Force by charge. And if you go for force unit, what is Newton? Charge unit is what? Coulomb. So what is the unit of electric field? Newton per coulomb. This is also known as volt per meter. Dimension you can find, you can see in here. Now what is the relation between E and F? As you know that E is equals to what? F by Q, no, Q. Which charge will be here? The test charge will be here, not the source charge. Source charge will remain fixed. If you want, suppose you have been given the force and you want to find the electric field, what you are going to do, you are dividing the force with the test charge. So force will be equal to what? Test charge into electric field. Now we will find the electric field due to a point charge at some distance. So you can see over here that Q is a source charge which is placed at O. Q naught is a test charge which is placed at P at a distance of R from the charge Q, and as both are the similar charges, similar kind of charges, that is the force of repulsion, which is what? F vector. Now you want to find the electric field due to this point charge. How we are going to find it? See, we know that F equals to what? 1 by 4 pi epsilon naught into Q1 Q2. What is the Q1 over here? The source charge. What is the Q2 over here? The test charge by distance between them, that is R vector square or R square. And when we know how to find electric field is obtained by dividing the force with the test charge. So F by Q naught. So you can see Q naught will be cancelled over here, and electric field will be what? 1 by 4 pi epsilon naught Q by R square. Okay, what was force? 1 by 4 pi epsilon naught Q1 Q2 by R square, but in the electric field only one charge will be there, and that charge will be what? That charge will be source charge, because when we divided the force with the charge, the test charge were cancelled, and what we have left in the final formula is the source charge, not the test charge. So from this you can see that electric field is inversely proportional to the square of distance from the source charge. Okay. Now electric field line is a thing that we have already done in class 10. Then also I am going for it. Electric field lines, you know, that is an imaginary line drawn from positive charge. It comes out from positive charge and goes to what? Negative charge. If there is only one positive charge, then it will always readily come outward. If there is negative charge, it will come inward, because we know that electric field come out of a positive charge and goes into a negative charge. If there is a dipole plus minus both in the diagram 3, then it will come from positive charge, it will go to negative charge. Okay. And electric field line is not a continuous curve, because it comes from positive charge and ends at negative charge. Okay. So it is not a continuous curve, it is a discontinuous curve. Okay. Definition you can see over here, the definition you can learn. Now what are the properties? What are the properties of electric field lines? We know that the electric field lines, suppose if there are two places, at one places the gathering of electric field lines is more, and at other places they are having some space between them, then what we can say, the place where they have gathered more, at that place electric field is more intense than the other place. Okay. Electric field line will always originate from plus charge and will terminate to the negative charge. Two electric field lines can never intersect each other. This is a question, very important question, that two electric field lines can never intersect each other, because if they do, then what will happen there? There will be two directions at a single point, which is not possible, because we know that if we draw a tangent at any point of electric field line, we will be getting the direction of electric field at that point, because electric field is a vector quantity. Okay. Now what is electric dipole? Two equal and opposite charges separated by small distance are known as electric dipole. As you can see in the diagram which is at the bottom of the page, there are two charges minus q and plus q. They are separated by a distance of 2a. Now sir, why you have taken 2a, why not a? That you will come to know in the later part only. Okay. So what is electric dipole? It is nothing but it is a combination of two charges which is equal, opposite, and separated by a very small distance. Now dipole moment is always represented by P. How to find the dipole moment? To find a dipole moment, of a dipole, what we will do, we will multiply the charge, any charge, either you take plus q minus q because both charges are same, any charge into the distance between them. So, it will be q into 2a, that is 2aq, and dipole moment is a vector quantity because you can see a vector sign over p.